Okay, I changed the talk a bit, so if you printed out the agenda in paper properly, so this has been changed on short notice. I'll talk about Scrona technology and a bit about what we do at Notion Systems. So let's start right in. Doesn't work. No, it works. Okay, so a philosopher's introduction to Notion Systems. So what do we do? We build inkjet platforms from laboratory and scale applications from laboratory to industrial production. That's basically all what we do. And there are things you have to accept if you do that, and things that you want to change. Things that we accept are standards. So electronic devices have to comply with strict standards. They are produced typically at high volumes and with high yield. So those are requirements that come from industry, and we want to comply with that with our additive manufacturing technologies. So what do we want to change in electronics? When you come across electronics manufacturing today as it is today, you very often see a lithographic process chain. So you start with a substrate, you coat apply a functional layer, you apply a resist, you expose the resist, you develop the resist, then you etch the layer, and finally you strip the resist and have your final device or your final layer. And of course this is done over and over again until you have a certain functional part, a certain functional device. So there are 6 process steps for each layer, and of course there are many, many layers in electronic devices as we have them today. So what's the advantage, or where can we provide value to this industry? And I see 2 main areas where we can do something with additive manufacturing in that process area. One thing is just printing the edge resist, of course assuming that the resolution that we can apply the resist in is the resolution that you require for the electronic device later on. Yeah. So we're not talking about nanometers, we're talking microns over here. Yeah. And the second thing, of course, the holy grail would be to print the function directly, but of course this involves also some ink development. You have to bring the functionality into the ink as you print, or as that you want to print. But it's still, you see the advantage of this of additive manufacturing here is to reduce the process steps, reduce waste, and make production more sustainable. We have done that for several applications in field. So they are running. We're talking about running production systems in field for displays, for display color filters, for PCBs, solder mask printing, for optics, for nano imprint lithography processes, semicon resist processing in power semiconductors, and some packaging applications. We have all of that. I can show you samples of that at our booth, so please come by and visit if you want to have more information. So so everything's good, yeah? So we have some application and we are in business. So what's next? What do we want to do next? Or what are the challenges that we have in this semicon industry? First of all, semicon is not a homogeneous industry. It's very, very heterogeneous. You have the CMOS, the very high resolution, a few nanometer resolution space. You have the MEMS, the power, optics, and micro display, and probably there are a few other areas that I haven't put in here. And of course, we can't provide solutions to everybody. So first things first. So power electronics, where you don't have very, very high resolutions, that's an application space or application area that we currently focus on. There are some applications in the MEMS area and in the micro display area as well. So what are the limitations of inkjet? Yeah, of course, there's every technology that you apply has some limitations, and the most crucial limitations that we have in inkjet